Welcome to Math Tutorials. In this video, we are solving every question of the miscellaneous exercise on Chapter 4, Determinants, from the NCERT Mathematics textbook for Class 12, Part 1. The miscellaneous exercise on Chapter 4 has 9 questions that stretch across the whole chapter: 2 trigonometric determinants, an inverse of a product, a double adjoint verification, 2 algebraic determinants, a system with reciprocal unknowns, and 2 multiple-choice results. Here they all are. Question 1. We must prove that this determinant, whose entries mix x with sines and cosines of theta, does not actually depend on theta at all. The plan is direct. Expand fully and watch every theta term cancel. Expand along the first row, writing the 3 2 by 2 minors. Evaluate each minor. Multiply out. The sine-cosine terms cancel each other immediately. Group the remaining theta terms. Sine squared plus cosine squared is 1, so they collapse to plus x, canceling the minus x. Only minus x cubed survives, no theta anywhere. Question 2. A determinant packed with products of sines and cosines of 2 angles, alpha and beta. The 0 in the second row is our friend. We expand along the first row and the identities do the rest. Expand along the first row with the 3 minors. The first 2 minors keep their cosine alpha factor. The third bundles into sine alpha times a full square. Factor cosine squared alpha from the first pair and sine squared alpha from the last. Each bracket is sine squared beta plus cosine squared beta, which is 1. And that identity gives exactly 1. Question 3. We are handed an inverse directly, together with a matrix B, and asked for the inverse of the product of B. The reversal rule says a B inverse is B inverse times A inverse, so the only real work is inverting B. By the reversal rule for inverses, we need B inverse first. The determinant of B, expanded along the first row, 3 plus 2 minus 4 gives 1. Cofactors of row 1 of B. Cofactors of row 2 of B. Cofactors of row 3 of B. Since the determinant is 1, B inverse is simply the adjoint, the transposed cofactor matrix. Finally multiply B inverse by A inverse, every entry as a row times column sum. The sums give the answer. Question 4. 2 identities about adjoints and inverses must be verified for this concrete matrix. Everything flows from the determinant, the adjoint, and 1 more round of cofactors taken on the adjoint itself. The determinant of A, expanded along the first row, 14 minus 18 minus 1 is minus 5. Cofactors of row 1 of A. Cofactors of row 2. Cofactors of row 3. The cofactor matrix is symmetric, so the adjoint equals it, and an inverse is the adjoint over minus 5. For part 1, we need the adjoint of the adjoint. Cofactors of row 1 of edge A. Cofactors of rows 2 and 3 of edge A come out in the matching pattern. And the last row. Transposing gives the adjoint of edge A, and remarkably it is exactly minus 5 times A. The determinant of edge A, expanded along its first row with these cofactors, is 25. Part 1, left side. The inverse of edge A is its adjoint over its determinant, which is minus 1/5 of A. Right side, A inverse is minus 1/5 edge A, and each cofactor of A inverse is a 2 by 2 determinant whose entries carry that factor, so it picks up 1/25. The 2 sides match. Part 2, determinants multiply, so determinant of A inverse is minus 1/5, and inverting A inverse divides its adjoint by that. The minus 1/5s cancel, returning A itself. Question 5. The 3 quantities x, y, and x plus y cycle through the rows of this determinant. We expand along the first row and simplify the algebra honestly, term by term. Expand along the first row. Evaluate the 3 minors. Multiply everything out and collect. The mixed terms cancel in pairs. Factor out -2 for the tidy final form. Question 6. A determinant with a column of ones, which is an invitation to expand down that first column. Almost everything will cancel. The answer is astonishingly small. Expand along the first column. The signs alternate plus, minus, plus. The minors are the square term, x squared, and minus y squared. Everything cancels except the single product term. Question 7. The unknowns appear as reciprocals, 2 over x, 3 over y, and so the system is not linear in x, y, z directly. Substituting u, v, w for the reciprocals turns it into a perfectly ordinary linear system. Let u, v, w stand for 1 over x, 1 over y, 1 over z. The system becomes linear in u, v, w. Matrix form. The determinant, expanded along the first row. 150 plus 330 plus 720 is 1,200. Cofactors of row 1. Cofactors of row 2. Cofactors of row 3. Adjoint times b over 1,200. The sums are 600, 400, and 240. So u is a half, v a third, w a fifth. Undoing the reciprocals gives x, y, z. Question 8, multiple choice. A is a diagonal matrix with non-zero entries x, y, z, and we need its inverse. We run the adjoint formula honestly. The diagonal structure makes it quick. The determinant of a diagonal matrix is the product of the diagonal, x, y, z, non-zero by assumption. The diagonal cofactors are the complementary products, and every off-diagonal cofactor contains a zero row, so it vanishes. Divide the diagonal adjoint by x, y, z. Each entry reduces to a plain reciprocal. That is option A. Question 9, the final one, multiple choice. The determinant of this sign-filled matrix must be pinned to one of the given ranges as theta sweeps a full circle. We compute the determinant as a function of sine theta, then read off its smallest and largest values. Expand along the first row. The first and last minors each give 1 plus sine squared, and the middle one vanishes. Sine squared runs from 0 to 1 inclusive as theta covers the circle, both extremes attained. So the determinant fills the closed interval from 2 to 4. Option D. That completes the miscellaneous exercise, and with it all of Chapter 4, Determinants. In the next video, we begin Chapter 5, Continuity and Differentiability, with Exercise 5.1. Thank you for watching. If you found this video helpful, do like it, subscribe to math tutorials, and share it with your friends.